The owner or operator of this electrical equipment told me that the unit is not running anymore, even though the switch seems to be switching and rotating. So that was off. This is position 1, power 2, and power 3 in position 3, and all the way back to off. The knob is rotating, but the unit is just not being powered. In this video I'll explain what your repair options are when it comes to repairing or replacing or dealing with the fault of a rotary switch like this, which happens to be a 4-position rotary switch. I hope that makes sense. And my solutions will range or will consider budget, time and practicality as well. There are a number of options. Before the options, these switches can be commonly found in small appliances, stationary and portable ones as well. It can be on a fan, a portable fan, or a heater controlling fan speed. In this case, this was part of an oil-filled radiator where electricity is distributed in a pattern that powers these heating elements here that are at the bottom of the unit and heat up the oil that's circulating inside the unit. Some other equipment can include other portable heaters that have glow wire in them, and the fan is pumping air or moving air through that glow wire. Or it could be stationary, as in not a heater but fan speed control, such as in the kitchen above your range or cooker or oven. So those would be some examples. Let's take a look at what's involved here in removing the switch very quickly. This is a Phillips number 2 screwdriver, as plain and simple as it gets. That's the only thing I needed for accessing the switch and removing the switch. The switch lives inside the unit here. This is where it is removed from, and nothing else was disconnected other than the 4 wires that go into the switch itself. It has the 4 wires enter the unit there, that's 2 spots, 3 and 4. The switch, otherwise the rotary switch, has a very straightforward knob that pulls off, and a 4mm shaft here. Very straightforward and very common. The switch mounts with these screws here that I put back into the switch's housing, and those screws go through the sheet metal cowling, or this front piece, or I'm not sure if it's a control panel, this whole piece of metal here that was covering the electrical connections here on this radiator. The screws that were removed were along the edge of this cowling, so in some cases I didn't even need a screwdriver. And there is one up here and 2 more small screws there. So none of these tabs were broken. Some of the connections are snap-in-place connections. So the 4 wires that lead into the switch are as follows in a logical order. Electricity or power comes in, of course, through the extension cord there and there. This is line or hot. This is neutral. The hot wire goes through, in this case, a tip-over sensor or a tip-over switch. It could be a main switch, or there are variations to it, but this is the line that is powering the switch, or and the hot or line goes into the port on the switch that is labeled. You can see they are labeled. Okay, that's upside down, but there's 1, 2, 3 and A. A is where the line comes in. Okay, so that's important how the switch is wired. So that's where this was. In spot number 1 there was a light bulb connected to it, and that means that in positions 1, 2 or 3 that small LED bulb is always glowing. In positions 1, 2 or 3 I have these 2 wires that are either one of them or both of them are powered, and they were on terminals 2 and 3. Now, what's wrong with the switch is that, and you can see some of this black dust here that's collecting there on the inside of this metal shroud or cowling, is that something is burnt out inside the switch. It's also evidenced by some deposit that can be seen on the line that goes into the switch. Just give me a sec to get a nice picture. And there you can see some deposit on this wire. Okay, and it should be shiny and nice, such as these two guys here that are intact. Alright, so there is something wrong with port A. This was port A, this is 2 and 3. So, your options. Here is the cheapest and the fastest option. Grab a twist-on electrical connector of appropriate size and twist the wires together, all 4 of them, why not? So you have a light indicating that the unit is on as well, but this can be omitted, it really doesn't do anything. The line that's supplying current to both of the heaters will need to be tied together. There, all 3 of them, you get the idea, and then it's repaired within 20 seconds. Problems with this is that, of course, this is the oil-filled radiator is subject to tipping over and moving. This might, this wire moret might come loose, shake loose, and be lost. So that might be an issue. This needs to be tied together, whatever, secured in a way so that this one doesn't fall off once it's twisted in place. Another issue with this, of course, is that you don't have a switch, any other switch on this one that turns the power on. So when you plug it into the wall, there's going to be some arcing and sparking there. As soon as you plug it in, it's going to be powered, full power all the time. So you're not going to have settings 1, 2, or 3 to choose from. Oh, I just found a nameplate on this one. This just happens to be completely, I'm not saying it's irrelevant, but there's the nameplate on this particular oil-filled radiator. So that's repair option 1. Repair option 2 would be just get a new one. And I was thinking it probably costs $1 or something, and I started shopping around in local local electronics stores. Of course, they don't have it. It's too big for any electronics. And electrical stores, such as small appliance repair places, they don't have just a switch. It doesn't matter what brand. It could be this one, Uber House, or Uber House, depending on the market, or Whirlpool, whatever. They don't really just carry one switch. They might, but there are problems with just having one switch. So good luck finding a part that matches exactly this situation here, or this particular appliance, or yours. I found some switches randomly online. Here is one of them. Let me just put you on the tripod. It's less shaky that way. There we go. So here is one of them. That's how it looks like. It's $8.49. It doesn't matter what market or what dollars, whatever. So there's this one, and it's apparently made in China and comes from China. Hence its name. 2-way, whatever. Rotary switch, 4 positions. Now, the problem that I want to point out is right here on the paper. Come on in a little closer. Maybe lower the camera a little bit. Thereabouts. You can see that it has, the positions are off. Line 2, line 1 and 2 are line connected with 1 and 2. Line connected with 1 and 2 and 3, so that means full power. That's nice, but I need one that's line 1 only, line 2 only, so that's there, not line 1 and 2 together. And I need line 1, which is the little light bulb actually, on all of these. So line 1 and 2, line 1 and 3, and line 1 and 2 and 3. So this doesn't match it. Now what do I do? So this won't work, but just for a rough idea, I found prices between $8 and $15. Now a new small appliance, if it's a portable heater, either with a glow wire or this kind, this is $70 or whatever. You can get a glow wire heater with a small fan for $30, something like that. So if the switch is half the price of the small appliance, your budget may not be for it, or you may not want to do this. I found a cheaper switch on Alibaba, a Chinese supplier again, on a Chinese website. So here is the Alibaba switch, the same thing, it standard matches everything. This one is 21 cents. That's nice, that's a realistic price for it, not $15 like I found in local parts supply stores for electrical appliances. However, again, the issue is, how is it wired? I need, like I explained, off L1 and 2, L1 and 3, and L1, 2, and 3. So I'm not sure, when this description doesn't say so, how the internal bits of the switch are actually built. So if you can't replace it with your part number and make and model number and everything, and you can't find one that's online, then you're just gonna have to take it apart and fix it yourself. It's fairly straightforward. That's what I'm going to do. It needs a putty knife. This one's a split or broken putty knife. Yeah, so make sure you're safe and you use tools that you are comfortable with. Yeah, and the small tweezers. Come on in a little closer and we'll get to dig. Let's see what's inside the switch that's actually burnt out and where the actual fault is. The switch comes apart or falls apart. It has these two crimp-on little tabs that can be folded out like so. There, I hope that makes sense. Maybe a little more, and they can be pushed back in place very easily. This is I don't know, mild steel, the very thin mild steel either, or some aluminum, whatever. And at this point the metal bit is going to separate from the switch like so. Just give me a sec here. The other side needs a little more bending and encouragement there. Alright, so this is going to mount back exactly the same way, and it's not going to be an issue. It's going to fit, so that's fit is not a concern. And these tabs, like I said, bend, very malleable, bend easily. They can be bent back, and then when you mount it back, it's still safe. So at this particular point here, you can see right away that it's melted right here where it says L on it, oh sorry, where it says A on it. Okay, so this is where the power comes in, and that's where it's melted. The top of the switch here comes off, and it has two index pins or two holes here that line up with two index pins here on the switch's housing here, nylon housing, one there and one there. You can see that the copper contacts are nice and clean here, here and here, and they are charred and somewhat disfigured over here at position L. At this point you might want to take the middle of the switch out, but I'm gonna have to show you something. You see this cutout here on the lid? Let me just put it back. It goes back fairly easily, just like so, compressing these spring plates a little bit and aligning the holes with the tabs. You can see how the switch rotates. You can see these tabs here on the shaft hit these holes, the sidewall of these holes in the lid that's cut out in this particular shape. So that's how the switch stops in the predetermined positions. Let's see, there. So it stops in this position with this tab hitting the lid in this position. Okay, I hope that kind of makes sense. Let me just rotate it back. There, that was the off position. So you might want to mark which way the lid was. In this case, my case is easy. The molten spot lines up with the A position of the switch here, and so I know that's how it was, and that's how it's gonna go together. I know that this is the A position, and this is, if you look at it as a clock, this was the off position here in the 11 o'clock position. Position 1 is, I don't know, close to 12 o'clock, 11:30. Position 2 is 12:30, and position 3 was around 1 o'clock, something like that. That would be my rough reference for putting it back together. So the middle comes out, and I'm going to show you the middle, what happened to it. You can see the charring on it, but I want to show you these copper plates here, that these provide some spring force to the rotating middle piece, and these come out just like so. That's how the switch went together, that's how it comes apart, and they are springy, and you can see the worn surface there where electrical contact is made repeatedly with this spring plate. Yes, I hope that's fairly straightforward. Springy. This is where the wire comes in. This little dented shape is where you push the wire in to make a connection when you put it back together. Alright. Of course, my hand doesn't quite fit underneath the camera. The camera is in the way. We'll just blame it on the camera. Okay, give me another 4 seconds. Alright, that's close enough. That's together. Of course, if you, and here is another repair option, if you cannibalize another appliance for another 4-position switch, such as this, the problem with this could be, even though this is nice from a washing machine and seems to be the same, you know, how is this going to be mounted? It doesn't mount the same way, and it's got 4 wires. The 4 wires can be connected, but you don't know how the inside bits, this is why I pull it out. Now, you don't know how the inside bits connect, which one with which one, and also there's one more issue, the issue of amperage. This one is rated, for whatever reasons, is 50-60 Hertz. There is either 125 or 250 volts AC, but is rated for 1 amp. That cannot possibly be true for both of those voltages, but whatever. 1 amp, and this was controlling on a Whirlpool washing machine temperature settings for the wash. So cold wash, cold rinse, warm with cold, cold with warm, whatever, and warm, something like that. Okay. Now, besides the obvious, the physical fit here is just impossible, very nearly to mount it on the cowling system of the oil-filled radiator, but also how the internals are wired in what combination, that's anybody's guess. Of course, it needs to be taken apart and looked at it, so that's also a repair option. But and you could go that way, but this one is probably simpler. Just take it apart and look at it. What's wrong with this one in terms of electrical contact is you can see it in this light. Okay, let me just focus the camera. You can see that this one that's burnt out, it's burnt out because there was arcing and sparking inside, and there was arcing and sparking because it wasn't making electrical contact, because it's misshapen. It's still springy, but it's compressed permanently. The switch is rated according to these two manufacturers, this Ningrui here and the other one on the other side of the paper, for 10,000 cycles. All switches are rated for a number of cycles, and within that number of cycles the switch will operate flawlessly. So you can see what happened. This springiness, it didn't melt. It's nowhere near the melting temperature of the copper, because this nylon is probably nylon 66 or something, and you can see some charring on the lower half of it as well. So this isn't melted, it's just sooty because of the arcing and sparking. It gets sooty and it gets arcing inside because this gets compressed excessively over time with just the pressure of the of how this rotating shaft middle here is running inside the switch. What makes the electrical connection here, and I'm not too concerned that the plastic here is also charred, that's not a problem, it's not a deal breaker. This is the key to the whole operation of the switch. This oddly shaped, lumpy thing here, which connects one part of this is where line is, so this is off, where this small bump here on this spring plate is lining up with this dimple, this dish here. That's when it's off, and this is position 1, 2 and 3. It's always powered, and in this configuration, let me see, this one with this one are connected or whatever across, you kind of get the idea. This copper piece also comes off. You don't have to take it off because it's completely unnecessary, but if you take it off, just watch out how it goes back together. Make sure that position 1 will be position 1 on your new switch, but there it is. They do come apart. I just have to match back the charred bits, and that's gonna be my position there for this one. And alright, I'll play with it later. And as for fixing the switch, I'm making it functional. I just have to bend this charred plate a little bit out like this so that it makes a better electrical contact. And how it holds on the wire is, this is also why I have this here, is very straightforward. So once it's in its normal shape and is in place, then it just holds onto the wire just like this. So there, and then it's in place. So you pull on it and it's not coming out. Of course, so to take the wires out from the switch, of course you need to compress that spring plate a little bit with a piece of a tweezer like so you can pull the wire out from it. Okay, so I hope that makes sense for repair options. I think my repair technique here is finished with this one. I just have to put it back together, maybe clean it a little bit here with say 600 grit sandpaper just there at the electrical contact point, so that it's, get you a close up there to make sure that there is actual positive nice electrical contact, and there's absolutely no arcing and sparking, because the sparking was here. You can see it on the surface of the metal, the bubbly or the residue, whatever, plastic dripping down, whatever is on it here, and not here where the wire comes in. Here, take a look at it. So it wasn't that the wire that's placed inside is loose there. That's not the problem. It was arcing and sparking here on this side where it was being pushed away from this little wheel. This one. So that's what's inside. That's gonna be my my repair cost will be $0 on this, and I'm hoping to see another 10,000 or so flawless switchings with this switch. Just put it back together the same way, wire it exactly the same way as it was. It will fit. It's not an issue. So I'm good to go.